All right, section 8.2. Now we're going to be doing some solving of oblique triangles where there is not a right angle. And so you have some cases. You'll either have 3 acute angles or 2 acute and 1 obtuse. And so here's a picture showing those two possibilities. And when you get ready to solve the oblique triangle, you have 4 cases actually. Case 1, you're given one side and 2 angles. Okay. Case 2, you get 2 sides and the angle opposite one of them. Then there's 2 other cases, case 3 and case 4, and I've just given you some notes that show you that. We're going to really focus on these 2 right here in this section for most of it. So let's look at a couple of examples. We need to look first at the law of sines that we will use for case 1 or 2. For a triangle with sides A, B, and C and opposite angles A, B, C respectively, you could always set the things equal. Sine A over little a is equal to sine B over B, or is equal to sine C over C. All right, and so that's what you need to remember, and we can use it with just 2 pieces at once. That's what we'll be doing. All right, now here is an example of actually using this law to solve the triangle. So the first thing we're doing is we're given one triangle, and we're saying solve it if you are given that A is equal to 40 degrees, B is 60 degrees, and side A is 4. So we can always get the third angle because they have to all 3 add up to 180. So plug in the 2 you know, and so you have 100 degrees there, subtract it. So angle C is equal to 80 degrees. And then we need to find side B and side C. All right, so we could do it, I did it in 2 parts here. I'll just draw a little line. All right, so I used the proportions that we're able to use. Sine A over A is equal to sine B over B. So I know angle A, angle B, and I know side A. So sine of 40 over 4 is equal to sine of 60 over B. You want to do it where you have one thing missing. Then because this is a proportion, we can just cross multiply. B times sine 40 is equal to 4 sine 60. We're trying to solve for this, so we divide this thing over here. So we have B is equal to 4 sine 60 divided by sine 40. You do have to be a little careful when you're doing those on the calculator. And I closed out the calculator. I need to bring it back up, so give me just a second to get this up. All right. So when we are doing this part down here, that should go away pretty quick. All right, so when we're doing it here, we've got it where we've solved for B, and we want to put this in the calculator. So the best thing to save you any trouble is to put the top in parentheses if it's got several things, okay? So we'll put a parentheses, which is above the 8, and we'll do 4 sine 60, close that parentheses, that's for the 60, and go ahead and close again, which it matches this one, all right? Divided by sine of 40. Now, if there had been a number in front of this sign, I would have used another parentheses around the whole thing, but I didn't really have to right there. We'll hit enter, and we should get 5.3, and we are rounding to 2 places. All right, so typically you want to put the top in parentheses, the bottom in parentheses if there's more than one thing. All right, we did the same thing over here doing sine C over C because we're solving for this side C now. So we had the same process. We end up with this, and we end up with 6.13. All right. Now, let's move down a little bit. Let's see. Okay. Case 2. 2 sides and an angle opposite one of them. This can result, we call it an ambiguous case because depending on what you end up with, you could have one triangle that you solve. It could be that there's two possible triangles, or there could be no triangle. So here's what those might look like. If it's no triangle, it means there's no way you're going to get a side that works. And we'll see one. I'll do one with you where you get no triangle. It's not possible. You might get one perfect triangle. Or you might end up where there's two possibilities and you have two full triangles. So we're going to do some of each. All right. Here's one where we end up with two solutions. All right, solve the triangle, and you're given the two sides. A is 6, B is 8, and angle A is 35. So let's use this proportion, and it will allow us to solve for angle B. Okay, so sine of 35 over 6 is equal to sine of B over 8. Again, we do our cross multiplying. We have 8 sine 35 equals 6 sine B. Divide by the 6 and you end up with sine B is equal to this business. All right, now we're looking for the angle. We know what this sine B is, okay? So one way to do it on the calculator, I just put the calculator screen here. I did this first and I ended up with this 0.76 long number. We don't want to really round right there. So although you might could and get the same answer, but it's very possible you wouldn't, you'd be off a little bit. So then you do second sine, and you can tell it to just pull this answer. So if you're on your calculator and you did second sine and you want this number to be pulled in, answer is right above the little baby negative down here. You would do second and the baby negative, which is down here by the decimal, and it would tell it to pull whatever the last answer was. So that is one way to do that and get that. So one of your angles is 49.9. It does tell you to round at that point. All right. Well, that angle is in the first quadrant. If you remember from, why is that not, interesting. That's really interesting. Why those are leaving. Let's see if we can move forward. This is a new computer and I am still getting adjusted to this particular screen. Okay, so I think I got that settled. All right, so one of the angles is 49.9. But another possible angle, remember sine is positive in the first quadrant and the second quadrant, and they have reference angles. So there's another angle in the second quadrant that would give you the same sine. So if you subtract the angle that we found from 180, we get 130.1. All right? And both of those, A plus B, are less than 180. And that had to be true. So, given that, C1, that third angle, is 180 minus our sum, and that gives us 95.1. That's using A as 35 and B as 49.9. Or 180 minus that sum could give us 14.9 if we're using A as 35 and B is 130.1. So we have two possibilities. Then we go on and figure out what C, side C, would be, but you have to do it with the 95.1. And then you also have to do it with the 140, I'm sorry, with the 14.9. So you get two possible C's. So you have two total triangles, all right? Because you had these are the same, but you got two possible angle C, and then you have the two side C's, all right? So here is one that ends up with no solution. So you're given a triangle. A is 2, C is 1, C is 50 degrees. So we start out, sine A over A is equal to sine C over C. Sine of A over 2 is equal to sine of 50 over 1. We do our cross multiplication. Sine A equals 2 sine 50. Well, 2 sine 50 is about 1.53, and if we remember, sine isn't greater than 1. It can't be greater than 1 or less than -1. So if you tried that in your calculator, you would get an error. So if this number is more than 1 on the sine, saying sine of this angle is 1.53, that doesn't exist. So you would have no solution, no triangle. All right? Let's try to look at our problems. We may not work all of them. I may not work all of them, although the work is here. Some of it's a little bit repetitious, and it'll be good practice for you. All right, so we have this triangle, and let's get us some more room. All right, so we're given 60 degrees here, 100 degrees here. This would be A, this would be B, and this would be C. All right, the value of A, well, we can say 100 plus 60, subtract that from 180, we'd get 20. So we know that angle. And then we could do the value of A. We've got sine of 20 over A equals sine of 100 over 6. All right. Cross multiply 6 sine 20 equals A sine 100. And I forgot that sine 100 right here. Okay. And so that would end up being 2.08. Down here, we're doing the same thing to get B. So you have 6 sine 60 equals B sine 100. Divide by the sine 100 to get B. Do these in the calculator, and you get 5.28. Pretty much once you get the law down, it is just calculator work after you get that done. All right. Same thing on number 2. You're doing the same process. And that should be pretty straightforward. I want to get to, let's see, number 3. Again, you're doing the same things over and over again. So the work is here, and that's on the lecture notes, but I think we've talked about that. But let's look at number 4. 2 sides and an angle are given, and I did write them in here. So this one is 30, side A is 6, side B is 5. And so you have 3 choices here. Either no triangles produced, 2 triangles are produced, or a single is produced. All right, so we start our work. Sine of 30 over 6 is equal to sine of B over 5. We do get 24.62 is B. All right, so that's my angle. Here's my angle. I'm so sorry. We did it here, and we got a 125.38 was our angle. And then we solved for the other 2 sides. And we didn't get a small angle where we would know there was another one over there. So we know there's just one triangle. Okay? But number 5... let's look at 5. We did the same idea. We put in the numbers that we were given. Sine of 30 over 3 is equal to sine B over 8. When you do your cross multiplication, sine B equal to 8 sine 30 over 3. And if you do that, you're going to get an error. It'll be a number bigger than 1. And so you know that it's no solution, no triangle is produced. Number 6 is 1. It's a multiple choice again, but let's do it. We've got 2 sides, 1 angle. So we're doing this, and we get, we are solving for angle C, and we got a 41.81. That's also could be in quadrant 2. So 180 minus that would give us 138.19. So we have C1 and we have C2. From that point on, we do everything twice. So if we're looking for angle 1A, we've got to do 180 minus, and we use this one. Here we use 180 minus, and we use this one. So you're going to get 2 angle A's. This is A1, this is A2. Then to get the sides, you're going to do the same thing, and you'll get 2 side A's. And when you go back up to how to put that in, it would be this choice. 2 triangles are produced, and then you can put in C1, you can put in A1, A1, and the triangle with the larger angle, you put its numbers here. So it allows you to put all of that in there. That should work fine. All right, on this question, Pat needs to determine the height of a tree before cutting it down to be sure it will not fall on a fence. The angle of elevation of the tree from one position on a flat path from the tree is h equals 60 degrees. So they've given you that here. And from a second position, L equals 60 feet further along the path, it is B equals 40 degrees. And that didn't come out right there. All right, so you've got one angle 60 degrees, one angle 40 degrees going up that way. All right, a couple of things that I wanted you to note, and I actually need there we go. Move my highlighter and come back down here. All right, this angle here is adjacent to this 60 that you're given, and so together they make 180. That makes a straight line. So I know that that angle is 120. I'm given that that one's 40, so that makes 160. That means that little triangle there has to be 20. Now I have all 3 angles, so I could do sine 20 over 60 equals sine 40 over this distance here, which I will need. All right, so I solve that and I get 112.76311 blah blah blah. All right, so we've got this 112, and now what we're actually trying to solve for is the height of the tree. So if you look here, so now we are ready to write this equation. Sine of 90 over 112 point, all those numbers, is equal to sine of 60 over the height. Cross multiply, and you get the height times sine 90 equals this business. Divide by the sine 90. So here's where we are. And when you do that, you will get 97.7 if you round to the nearest tenth. So we did have to do a couple of things to get to that. And just a reminder, we had to know that these were adjacent, and so that made that 120. Then we could figure out the 20. That helped us get this side here, and so we used that then to get the height. The last question has to do with the Leaning Tower of Pisa. It was originally 187.5 feet high. At a distance of 124 feet from the base of the tower, the angle of elevation to the top is found to be 64 degrees. Find angle RPQ. So you're supposed to find RPQ. And also find the perpendicular distance from R to PQ. So they want to know this angle, and they want to know this line right here. Okay, it's not in the picture, but that's what we're asked to find. All right, so to find the angle, we can do sine of 64 over 187.5 is equal to sine of R, remember this is up here, over 124. So that's going to give us that angle. So you do your cross multiplying, and you end up with sine of R is equal to this business. Remember that you will do second sine to actually get the angle. Then you can subtract the sum So you're going to subtract the sum of that angle plus the 64 because we're asked to find RPQ. So we're finding this one. And ultimately, we got R from our little equation here. So this was 36. This one was 36.47. You add those two together, subtract from 180, and you get the 79.5. And then we need to find this distance here. And so that's the next part of what we're doing. Sine of 90 over 187.5 equals sine of 79.5 over the height. Okay, so 79.5 over the height because it's the opposite of it. That's the deal there. And so you do the same thing and you get 184.36 for that one. So you are using a lot of the trig functions. You're using the law of sines in this section mainly. So I think that will get you through the problems for section 8-2.